Let's look at another application of arrays. I once saw a magician perform a card trick in which he shuffled the deck of cards a bunch of times, and then he had an audience member choose the fifth card from the top. And when he did that, the magician knew what the card was. He explained to us that the way the trick worked is that without us noticing it, he placed the card he wanted the audience member to choose such that it would be fifth from the top. And then he performed 8 perfect shuffles. It turns out that when you perform 8 perfect shuffles on a 52 card deck, instead of completely randomizing the deck of cards, which is what the audience thinks is happening, in reality, it puts the deck of cards back in the original order. So if this is my deck of cards, and we'll start counting from the bottom. So at the bottom is card 1, card 2, card 3, all the way up to 51, 52. Of course, when we shuffle, we divide this into 2 subsets, right? So I have what goes in my left hand, which I'm going to say is the bottom 26 cards. So 1, 2, 26. The right hand will contain the top 26, so it's cards 27, 28, up to 52. Then when you shuffle, and by that I mean recombine, if you're performing a perfect shuffle, you're taking 1 card from each of the 2 subsets. So if we have left be at the bottom as the first one that goes down, you would have card 1 here, then card 27, then card 2, card 28, up to card 26, and card 52. And then repeat 7 more times, and you get back to this. So I've always wondered if that was actually true, and now I decided to write a program to do it, or to test it out. So that is a good application of arrays because I need to keep track of 52 integers. And I certainly wouldn't want to have 52 individual variables in doing that. So let's see how I go about doing that. There's a couple of things I need to think about though in terms of keeping track of values. So I'm going to start off by creating my deck of cards. So int cards, there'll be 52 of those. And the initial values will be 1, 2, 3, 51, 52. Why not keep track of, aces and diamonds and hearts and all that? Because that doesn't really matter. All we're stating is that the order will return to whatever it was originally. Now the indices into this array will be 0, 1, 2, over to 25, and then 26, over to 51. These numbers, 1 through 52, are the original values of the cards, but the indices into the array will always be from 0 to 51. So I want to divide this into 2 subsets. So I want a left array that stores 26 numbers of type int, and so it will store what are at indices 0 to 25 from our cards array. And then I'll have a right array that stores 26 integers that will contain the values of those cards at indices 26 to 51. So how do I go about getting these values and putting them here, and these values, putting them here? So this part's easy. If we think about it and work through an example, I see that, okay, for left, I'm just going to abbreviate to save some writing. Left 0 will be equal to C0, where C is for cards. Left 1 will be C1. Left 2 will be C2, and so forth. So in the code, I can simply write this. Left sub I is equal to C sub I. That's easy to do, to have a loop go from 0 to what would be 25 in this case. What about for the right? Well, the indices in the right array will also be from 0 to 25. So I need to have R0 equals something. R1 equals something, R2 equals something, all the way down. But what's that something? Well, this went from indices 0 to 25, so this needs to start at index 26, which makes this index 27, which makes this index 28. So I have a couple ways I could go about doing this. I could have separate counters for each of the indices, but if I look closely, I see there's actually a functional relationship here. So what is 26? 26 is equal to 0 plus 26. 27 is equal to 1 plus 26. 28 is equal to 2 plus 26. So these numbers right here are my loop variable I, if that's what I'm using. And then I just add 26 to it. So my relationship here on each iteration of the loop will be R sub I, that's an I, equals C sub I plus 26. And I can reuse my loop variable for both parts. That's not that difficult. Recombining these then required more of a challenge. So let's see what would happen. Remember, when I recombine these, I need to store them in an array, and I'm just going to reuse my cards array because I don't need the original values anymore. I just care on each iteration of the loop to see what the current status of the cards are. That is, what's the ordering of the values. But in terms of the output, I need to have that C sub 0 gets L sub 0. That is, the first value in my new deck of cards will be the first value from L. But then the second card in the deck, that's at index 1, needs to be right 0. Right? Because I'm picking one of these, then one of these, and one of these, one of these, one of these, one of these, all the way down. We'll have a little line here to separate this part. So that means in C2 will be L1. Now I'm taking the second card from each subset. C3 is equal to right 1. C4 is equal to left 2. C5 is equal to right 2, and so forth. So what I decided to do is, for these indices here, I'm going to use a variable k. Because right here, k is equal to 0. Right here, k is equal to 1. Right here, k is equal to 2, and so forth down. Now what about these? I have a couple of approaches. One is, I could generate all 52 indices and then write some logic such that I'm alternating on each iteration as to which one I assign. So I say C0 equals L0, and then on the next iteration of the loop, I say C1 equals right. The next iteration of the loop, you use left. The next iteration of the loop, you use right, and so forth. But instead, what I decided to do is this. I'm going to call this variable I. So I will be equal to 0 initially. The loop will run as long as I is less than 52. But I'm going to increment I by 2 each time. And then the way I'm going to write this code is on each iteration of the loop, I'm going to say C sub I is equal to L sub k, and then C sub I plus 1 is equal to right sub k, or R sub k. So this is why I'm skipping 2. So this right here is an iteration of the loop. And this is an iteration. And this is an iteration. So when I is 0, I have C0 and C0 plus 1, which becomes 1. Then I increment I by 2, so now I will be 2. So I get C2 and C2 plus 1, which is 3, and so forth. That's how I keep track of it. It's one of several different ways to do this. So now let's write the code to actually do it. So int cards. I need space to store 52 cards. Now I could come in here and hard code the 52 values, but why not just use a loop and be smarter about it? So that's what I'm going to do. For I equals 0, I less than 52, I plus plus. Whoops, what did I just do? All right. And cards I equals what? Well, the first number I store needs to be 1, not 0. And the second number needs to be 2, not 1. So I'm looking for a functional relationship, and that relationship is I plus 1. Cards 0 will equal 1. Cards 1 will be equal to 2, and so forth. So if we want to put a comment in here explaining what I'm doing here, I'm initializing the deck of cards. Right. So now let's just check this, since I'm going to have a function to print out the current status of the deck of cards. So let's say print cards. And certainly I need the cards, but I'm also going to pass in a number. So let's use a smaller value instead of 52, because 52 will wrap. Now eventually I'd want to look at all 52 values, but this will be okay for testing purposes to get me going. Now we'll notice in some of the functions that I write, or in fact the other function I'm going to write, I'm going to hard code to this particular problem, because as far as I know, shuffling or performing 8 perfect shuffles works on a 52 card deck. I don't know what it would do with other numbers of cards, although you could check it out by just writing a program to do it. However, I am going to pass in the number of cards to print, because now it gives me some flexibility to look at a smaller set for test purposes. So my print function doesn't return anything, so its return type is void, print cards, and it receives an array of type int as well as the number of things to print. So I give it that. So int I for I equals 0, I less than length, I plus plus. Now let's print on the same row, so there's no new line, %d, but a couple of spaces separate, print, and I'm going to use card sub I. Right. And eventually I want to print some new lines to separate from anything else that gets printed. So let's see what happens. So C89, X, and there's my 10 values. So we could make this smaller, make it larger, but that at least convinces me that I did initialize this correctly. Because the mistake that would be easy to make would be at the beginning probably, which of course trickles through. But if I had 0 here, that would point out to me I'd made a mistake or whatever. All right? So now let's write the function to perform the shuffling. Shuffle cards. But now, as I started saying a moment ago, and then I moved on to something else, I'm not going to pass in the 52 because I am going to hard code this particular implementation to a 52 card deck, since that's specifically what I'm investigating. And I don't know that this works with anything else. But I could do that if I wanted to. Actually, I could do some things we haven't discussed yet to just populate everything with 52 if that's what I want to use, but we'll go with this. So the return type is void, but I need to get my array of cards. So let's say C is what we'll call it here. Doesn't matter. Now I need to get rid of that semicolon. And we said I'm going to need 2 counting variables, so int I and k. And then we need memory to store the 2 subsets of the deck of cards. So int left will store 26 cards, and int right will store 26 cards. Now you might be tempted to do something like this. Left equals C. But that would be wrong. Now, even if this worked the way you thought it would work, it would be wrong in this case because left allocates memory for 26 numbers and cards has 52 numbers. But that's not actually the problem. The problem is I can't assign arrays in this form. So let's see what happens when I compile that in terms of the error message. Error, assignment to expression with array type. left equals C. So it is telling me that's wrong. So how do we actually get those values? Well, I have to go through there one by one and copy them over. That's why I had the I variable. So we'll do this. And we said on each iteration loop, I need to write L sub I is equal to C sub I and R sub I, or right, sorry, in my code this is right and left. C sub I plus 26. So let's check these and see if these appear to be correct. So now I'm going to take this function call and come down here, and we'll just look at the first 10 of each of these. So left should have the values 1 through 10, and then this should start at values 27 for right. So 1 through 10, and then 27 through 36. So these are getting the correct values. Right. So we'll reuse this here in a moment. And so let's see what happens. Well, now we recombine the two decks. So we said for this, I'm going to write 4. I is equal to 0, I less than the 52, I plus equal to on each iteration. And we need a value for k, so I could either do it here or I can do it here, so let's do it here since that's where I'm at. It uses a comma here because it's in the initialization section. K is equal to 0. And we said that C sub I is equal to left, so K, and C sub I plus 1 is equal to right, so K. Let's line these up, make it a little easier to look at. And let's see what happens after one shuffling, since we know what the answer for that should be. One, whoops, what did I mess up here? Oh, I forgot to increment K, sorry. So when does that happen? Well, essentially after I've used it completely. So that goes over here in the section where you increment variables or decrement or however you're changing it. This would be K plus plus. So see all the ones, and then the 27s, they all stay the same. So 1, 27, 2, 28, 3, 29. So we are going back and forth like I expect. All right. So now let's do it 8 times. So let's come back up to here. And we'll shuffle 8 times. And let's put a print statement in here that tells us which shuffle we're on. So this will be shuffle number %D, and this will be I plus 1, because I want it to say shuffle 1, shuffle 2, not shuffle 0. Now let's see what happens. We'll do the first 10, then we'll look at everything. One through 10 at the end. So we didn't print the original. We could have done that. So the original. Let's put 52 in there. And that's what we'll do with this as well. So original deck. Original deck, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way through 50, 51, 52. So it looks correct. Here's my first shuffle, 1, 27, 2, 28. Gets down to the end like we said, 25, 51, 26, 52. And then eventually at shuffle 8, 1 through 10, keep going. 50, 51, 52. So it does work. So this just demonstrated that. So hopefully you can better appreciate several things that we did here. There's many times when using arrays in which we will simply just go through like we did here and just go from 0 up to some number and work directly with things. But as we also demonstrate at the bottom, in order to use arrays in a much wider number of situations, sometimes we have to become clever in how we're incrementing the indices. And hopefully you got the point of that here. All right.